All right. So to start out, please read chapter one, section one of the textbook. If you have not, that goes along with these lectures. This first section that I'm going to go over is just some of the basic terms that you'll need in order to do well in this class. They're terms that are going to come up over and over again, and just some concepts that will come up over and over again. So we're going to start here. First of all, what even does statistics mean? Statistics uses data first and foremost. So this list of numbers that you see up here, this is my hand cuts off when I do that. I'm learning how to use this interface. Anyway, this list of numbers that you see up here, that's the ages of a group of kids playing at a park. If we're referring to the entire list of numbers, we call that data. That is actually a plural word. If you're talking about just one of those little pieces, one single age point in here, that's a datum. You won't really hear that word much, but data. So when we do calculations of different sorts with these data, there are two main categories of calculations we might do. One is descriptive statistics. So if our goal is just to summarize the data that are there, so figure out on average, where do the data fall, then that's descriptive statistics. Okay. If instead our goal is that we want to be able to answer questions about the data in the population, so we'll come back to population and sample in a minute. But basically, if we want to be able to answer bigger questions about the data that we have here, then we have to do inferential statistics instead. So inferential statistics, that's when we're calculating usually on a smaller group of individuals' information and then making conclusions about a larger population. So those are some of the basic terms you need to know: data, descriptive statistics, and inferential statistics I will refer to repeatedly. You also need to know the difference between a population and a sample. So a population is the entirety of a group that you want to study. So if you are doing a quality control study on hot dogs, the population of interest is every hot dog in the world. If you are doing a study on Los Angeles Harbor College students, the population of interest is every single student at Los Angeles Harbor College. Okay, so it's every single individual who is part of that group. The thing is, we usually are not going to be able to, even if we wanted to, gather data from that entire giant group, right? So instead, when we're doing research, we try to get a good representative sample. So a representative sample is one that matches important characteristics of the population you're interested in studying. And we'll talk a little bit more in a few sections about how we choose a good sample. When we are choosing individuals for a sample, that is called sampling. And so we might randomly select a group of 100 students if we wanted to study the population of Los Angeles Harbor College students, right? Or if we're trying to study every single 5-year-old in the world, then we might get the largest list of 5-year-olds that we can and randomly sample 500 individuals from that. So that's population, sample, and sampling. Population is everybody. Sample is the smaller group. Sampling is the process of going from a population to a sample. So population, sampling, down to a sample. Next, variables, parameters, and statistics. So when we are gathering data from a sample or population, again, usually a sample, what we're typically gathering are data that measure particular characteristics we're interested in. And we will gather that same data for a bunch of individuals in the sample or population. Okay, those characteristics that we're interested in are called variables. Okay, so variables are things you can measure for every individual in a population. And then data, those are the actual values that we use to measure that variable. So the variable is the bigger thing. Each datum that is given as a response for a variable, for or a question about a variable, that's part of the data that we use to represent the variable. Okay. When we do calculations on these data, what we call the values that we're calculating, differs a little bit depending on whether it's from a sample or a population. Again, most of the time we will be using a sample. And when we are doing calculations of or determining numerical characteristics for a sample, that is called a statistic. Okay. When we are doing those same calculations, literally the exact same calculations, but for a population instead of a sample, for the full group instead of a small group, then we call those parameters. Now, again, realistically, we don't, I'm in front of my definitions here. So the numerical characteristics, that could be things like averages, it could be things like probability. We'll get into some of those specific things we might want to calculate later on. But the important thing here is that if you're doing the calculations for a sample versus a population, it is called something different. And we also, you're going to end up learning some literal Greek in this class. And anytime that we use a Greek letter for to represent something, that usually means that it's a parameter. It usually means we're talking about a population, the full group. Often those are theoretical, meaning we don't actually have access to all the data we would need in order to calculate them. And so they often are things that we might be given to use as part of a different calculation. If we're calculating stuff off of a sample, so most of the things you'll calculate in here, unless I tell you that I give you the entire population's data, we will call statistics. Couple of other important terms to differentiate between are quantitative and qualitative. So, quantitative data, quantitative involves quantities, quantitative quantity, right? So, a quantity means like an amount. That's something that you would measure using numerical data. So, or count. And that would still be numerical data. So, if you wanted to know everybody in a population's height, then you would measure that using some kind of ruler or yardstick or tape measure or whatever. And you could measure that in inches, fractions of inches, centimeters, fractions of centimeters, whatever. Number of siblings, you could count the number of siblings. Both of those are considered different forms of numerical data. We'll talk about the differences between those two types of numerical data in a couple sections. Qualitative data involves qualities, meaning not quantities, not amounts, but qualities, like descriptors. Right. So when we're talking about qualitative data, we're usually not talking about numbers, or even if we use numbers to represent a qualitative thing, like on a scale, if you're rating from one strongly disagree to seven strongly agree, those are real numbers. We'll come back to what real numbers means later on. But qualitative data involves qualities, things where you would answer in words or on a scale where the numbers aren't really numbers. Okay, it is important to note that numerical data can be grouped into chunks and then treated like categorical data. So just because something starts out as numerical doesn't mean it will stay numerical. We also sometimes assign numbers to categories to help us work with them for certain statistical purposes. So things can get a little bit messy, but the main idea is that things you can measure, like with an actual measuring device or count, that's typically quantitative. Stuff that's more about qualities, about descriptions, that's more subjective, that is qualitative, and that's often categorical data, or typically is categorical data. So, a quick cross check for you. Take a moment, if you will, pause the video, and decide whether each of these would be quantitative data measured with a quantitative variable measured with numerical data, or qualitative and measured with categorical data. So give yourselves a moment to do that. Really, pause the video. Okay, so hope you're ready for the answers. These are the numerical ones. So age, that makes sense, right? We would typically measure that in years. Number of pets, it's a number. Temperature, a number. Weight, number of languages spoken. Height, shoe size, arguably a number, although kind of depends on American versus European sizing. It is a number, but the European sizes are more meaningful than the American sizes. Check with me in office hours if you want that one in more detail. Categorical stuff, this is the categorical stuff. So number of pets is quantitative, type of pets is qualitative. Okay, how many languages you speak is quantitative. Which languages you speak is qualitative. So all these other things listed on here are qualitative variables that would be measured using categorical data. It's important to understand the difference between quantitative and qualitative data because it impacts what you can do with those data. So we'll come back again to descriptive statistics later on, but some basic descriptive values that you might calculate. One would be a proportion. So a proportion is a number that represents part of a whole. So how many individual pieces of data out of the whole data set have a particular response, for example. So these are things that are calculated based on frequency. If you've got this data set here and you want to know the proportion of four or the probability that if you pulled a random number out of here, you would get a four, then you would count how many fours there were. There's two of them. You would count how many numbers there are altogether. There's 10 of them. You would divide that part over whole and you get 0.2. You can do the same thing for this list down here. You've got a list of hair colors here. If you want to know the proportion of blonde individuals, you can count. There's two that are labeled blonde. There are 10 in total, so it's the same thing. So these frequency-based descriptive statistics, let me get out of the way. Those can be calculated for both numerical data, like in the first example, and categorical data, like in the second example. Other statistics, though, you can't do that. So a statistical mean, which is the same as an average, which you've calculated in other math classes, I'm sure. Um, this is actually calculated based not on how frequently values show up, but what the values are. So for this first list, we'll say this is a list of ages, you can calculate the mean, you can calculate the average because you can add those values up and then divide by the number of values. So you add each individual piece of data and then you divide by 10 because that's how many numbers there are here. You get 5.4. But you can't do that here because you can't calculate that value for categorical data, for qualitative data. So some of the statistics that we'll do, you can calculate for any type of data, but a lot of them you have to have numeric data in order to make it work because you have to be able to do calculations with the individual pieces of data. All right, so that is going to do it for this section. This is a great time to stop and try the first exercise, the one that goes with part one.